Hello, today I will be going through the process of making a generic robot in Blender, and with the help of the add-on for AMBF, we will be generating ADF files for the robot. I will also be rigging the joints of the robot and generating this in AMBF. So firstly, we'll open up Blender. So just open up Blender and close the initial pop-ups. Hold on. Close the initial scene, run the script, the AMBF add-on script, and go back to the layout tab. And you can begin with the process of making the robot. I will be speeding through this part as this is not a Blender tutorial. So I will see you when I am finished. So after creating the robot, the generic robot, we need to rig the joints. So I'll go through the process of rigging the joints in the 3 axes, so the X, Y, and Z. So we'll start off with this one. So zoom in. I guess the first command is to set the cursor to selected, and then in the AMBF tab, you click Create Joint. I'm still in edit mode, so I'll switch off to edit mode. So the 3D cursor is still there, and we'll click Create Joint. Then you set the constraint to so the first one's the parent, so that's just the base. So this prism. Second is this arm, right? So let's go back to joint, and that's the child. So it's just the arm, and then we set the constraint. Again, parent is just the arm, or sort of base, and the child is the arm, the first one. And so the joint axis is the z-axis, so it's going to be able to rotate on the x-axis, sorry, on the z-axis. So that's fine. So then the next, so I guess I'll just name this properly. So that's the joint. So that's that joint. So after rigging the joint on the z-axis, we'll rig the joint on the x-axis. So let's go into edit mode. So let's select the 2 rigid bodies, the joint. So shift select both and tab into edit mode. So just select them. And then shift S, cursor to selected. So now the 3D cursor is at the interface of the 2 joints. So after that, go into object mode. Notice the cursor is still there. So create joint and then rigid body constraint. So now the parent is the arm right here, and the child is this pin. So we'll set that in the joint along the x-axis. So the arm and then the arm pin. Then enable AMBF constraint, again, arm and arm pin along the x-axis, and it will save everything. And let's just see this in action. Let's just delete these old ADF file and the meshes, and write new ones to the repository. And let's launch this in terminal. Notice I'm using this command AMBF simulator, just the add flag and the location of the ADF file. So that's default.yaml. And this is the ADF file that our Python add-on generates. And let's just launch this. And this is what happens. So notice we have joints along the z-axis at this end and this end. Obviously, we haven't made joints for these last two interfaces. So this end and this end. That's why we get this detached bodies in AMBF. So let's go on and fix that. But currently, we have the joints along the x-axis on the pin and at the base in the z-axis. And I will showcase this movements in AMBF using the Python client once I'm done. So let's go ahead and create the last two joints. So select the two objects and tap into edit mode to the wireframe view. And box select the interface and Shift S to cursor, to the 3D cursor to selected. And go back to object mode and create the joint. Let me make sure I name this properly. So let's just generate the name convention. And let's put the name here to make things more clear. So this is our new joints. So rigid body constraints. So now the parent is this arm, the child is this arm too. So let's go and configure that in our joint. So first, the arm, and second, arm 2, enable AMBF constraint. The parent is the arm, child is the arm 2. This is also on the x-axis. Let's just verify that. Just close, delete this previous BFL mesh. Let's open. Let's close the instance of AMBF and open our updated bottom. And we get this. So this is looking good. As you can see, the inertia of this mesh is torquing the base of the bottom. So let's fix this last joint. And let's go back to Blender. So Shift select, tab, go into wireframe view, then box select the interface, Shift S, cursor to select it. That's good. Okay, so go back into object mode and create our last joint. So now the parent becomes arm 2 and the child is the end effector. So just make sure we get that. Oh, okay, so I forgot to name this joint. Just copy this. Okay, so things are more clear. And then we'll set the body constraint. So again, on2 is the parent, and the last child is the end effector. Enable AMBF constraints. Parent is on2, and the end effector is the child. This time, the joint axis is on the y-axis because we want the end effector to turn on the red. So the x-axis. So no, sorry, no, the y-axis. So the green axis line. So this joint will sit along or about the green axis. So the y-axis is the green axis. So let's save everything. And let's update models. Write the AMBF description file and save our mesh. Let's open up terminal and launch AMBF. Interesting. So the joint and this R2 doesn't seem to be perfectly aligned. So let's just see what's going on here. Okay, so this part's a bit tricky. So take a notation. Let's move our 3D cursor. So let's delete this joint. Okay. Let's update our 3D cursor. So select this tab. It's wireframe. Select. Actually, I think I'll just fill this. Hold on. Okay, so let's select the space, space. Cursor selected. So we've updated our 3D cursor to just be at the edge of these two meshes. So let's recreate our joint. Let's go back to object mode, recreate the joint, rigid body constraints. So on2 and end effector. Enable AMBF constraints. R2 and end effector on the y-axis. That should be good. Okay, so let's save everything. Let's see our results in AMBF. So if we see this, this is our output. So in AMBF, so this is fine, everything looks good. But what's going on here is because the inertia of the object is leaning along this direction, it's causing the object to flip over. So I think I'll just modify some inertias and masses, and I'll show the final results in AMBF. And then we can use the Python client to modify our joints and see the resulting effects. So I'll see you there. Okay, so we're back. So here is the final product. All I did was just increase the mass of this base block, and that seems to fix the inertia. It seemed to stabilize the model. So now let's open IPython, which is just the Python client that I'm using. The command line Python. So IPython. So thanks. It's connected to us publishers. And if we check object name is currently AMBF. See the end effector, the arms, and the base are all there. So let's create a handle for the base. The base. Okay, so it's our handle for the base. And so the base is torquing along the z-axis. So because the base is the main parent, it has access to this joint, this joint, this joint, this joint, and the end effectors joint. So let's just confirm the joint index. So sure. So it's not that. So we want the joint going from the base to the arm. So yeah, so it's at the text number 2. So here, start set to effort. So next to the value of 10. So as you can see, there is a limit. I think it was 60 degrees. We go to the joint. So from arm to base, or just say base to arm, the limit was 60 degrees. So that's why it doesn't revolute. Let's go back. Let's set the effort along the opposite direction, and that's fine. Perfect. Okay, so now let's get a handle for. We can either get a handle for their other links, or we can just operate the links as the base is the parent of all the other joints. So we can just do that. So the next joint goes from arm to armpit at index 1. So we can just draw next one where the joint is located. And so I think it's a bit closely. You should see this rotates. I should have had it added grooves along the arm pin just so we can verify it's working. But it's not very evident. But if you look carefully, it is torquing. So let's turn this on the x-axis. Very carefully. So, as you can see, it is working. And we can get a handle for this end effector joint, which spins along the y-axis. So that goes from arm to end effector. It's at index. So just push this. You should see this end effector torque on the y-axis. As you can see, it is torquing. That is perfect. So that is it for this video, and now hopefully you should have a better idea as to
how to create models in Blender, generate their ADF files using the AMBF add-on, rig their joints, and launch these models in AMBF, as well as using the Python client to interact with these models. Thank you.